Hello, my name is Axel Scherer. I will give you a quick introduction into virtual interfaces in UVM. UVM is great. You have a very dynamic system that can build a complex verification environment and do constrained random test generation and all that good stuff. But there's one challenge. How do we connect from this virtual world into the real world? In other words, how can we connect this dynamically generated environment to the static RTL model? This is what virtual interfaces are all about. Let's look at our UVM environment. Again, we have a test bench. It's virtual, right? It's dynamically generated. And we have the DOT, which is a static model. We need to bridge this gap. So basically our UVCs, interface UVCs, have to somehow talk to the DOT. How do we establish that connection? Another way to look at it is looking at an interface UVC for an RTL model. The driver has to talk to this interface and the collector has to do the same thing, right? But all of those guys are living in the virtual world again. They're dynamically created. We need some method to hook up. So let's look at some code for this. We have an APB master driver as an example here. And as you can see, it has a virtual interface, virtual APB interface, instance called VIF. So this is the way we can reference an actual system Verilog interface that is existing in hardware, where all the wires associated with an interface are basically bundled up and can connect and talk to it. So in other words, once you want to drive particular values onto a signal, we can use this virtual interface. Here, for example, we're putting reset values onto the APB bus, right? So we're not directly accessing that APB bus. We don't know what that is, but we have this reference from the virtual interface, so we can drive 0 onto the address bus and data bus and so forth. So the virtual interface is basically bridging this divide between the two domains, and we can also quickly have a look at where do I have that? An actual APB interface. So here's a hardware APB interface. You can see it has a bunch of parameters that are associated with APB, and it has all the related signals, also some other controlling flags. So this thing is actually instantiated in the RTL model, and with our virtual interface we can actually talk to it. You can find more videos like this either on this YouTube channel or at support.cadence.com at the video library for the Incisive Simulator. Thank you very much, have a great day, and talk to you soon.